Through the Eye of the Wormhole: Science, Fiction, and the Truth Behind Interstellar. In 2014, Christopher Nolan's film Interstellar captivated audiences with its breathtaking visuals and mind-bending concepts, particularly its portrayal of black holes and wormholes. The movie followed Cooper, a former NASA pilot, who travels through a wormhole near Saturn in a desperate mission to find a new habitable world as Earth faces ecological collapse. While it dazzled viewers, it also left many wondering, how much of this is actually based in real science? Are wormholes and black holes as portrayed in Interstellar real phenomena, or are they purely science fiction? The answer is complex, a blend of scientific theory, speculative physics, and cinematic storytelling. Wormholes, a theoretical shortcut through space and time. A wormhole, also known as an Einstein-Rosen bridge, is a theoretical tunnel connecting two separate points in spacetime. Imagine the fabric of the universe as a two-dimensional sheet. If you fold it so that two distant points touch, then punch a hole through both layers, the tunnel you've made would be a wormhole. This concept arises naturally from Einstein's general theory of relativity, which describes how mass and energy warp spacetime. Wormholes have never been observed, but the mathematics behind them is valid. They were first proposed in 1935 by Albert Einstein and Nathan Rosen. The idea suggests that wormholes could allow instantaneous travel across vast cosmic distances, potentially even between galaxies or different times. However, there are serious challenges. A wormhole, if it exists, would be highly unstable. The gravitational forces would cause it to collapse faster than anything could travel through it. The only theoretical way to keep a wormhole open is by using exotic matter, a form of matter with negative energy density. This kind of matter has not been discovered in nature, although it appears in certain quantum theories. The wormhole in Interstellar. In Interstellar, the wormhole near Saturn was placed there by an advanced civilization known only as they, presumably future humans or some benevolent higher intelligence. While this is a fictional element, the visual and structural representation of the wormhole in the film was grounded in scientific advice. Kip Thorne, a Nobel Prize-winning theoretical physicist, served as the film's scientific advisor. He ensured that the wormhole's shape and behavior adhered as closely as possible to the mathematics of general relativity. Unlike the classic depiction of a wormhole as a swirling vortex, Interstellar shows it as a sphere, which is accurate. From the outside, a wormhole would look like a black orb reflecting light from the other side, similar to how the film portrayed it. Though the notion of traveling through it remains speculative, Interstellar gave us the most scientifically credible depiction of a wormhole ever shown in cinema. Black holes in Gargantua, the behemoth of the cosmos. The film's central celestial body is Gargantua, a massive spinning black hole. Its representation, especially the glowing accretion disk bending light around it, is one of the most visually iconic images in modern cinema. Once again, Kip Thorne provided the equations used to generate the visual model, which were so precise they contributed to academic papers on gravitational lensing. Gargantua spins near the speed of light, which drastically affects time for objects close to it, a phenomenon known as time dilation. When Cooper and his team land on the water planet near Gargantua, every hour they spend on the surface equals 7 years on Earth. This is scientifically plausible, though the degree of time dilation is at the extreme edge of theoretical models. It would require the planet to orbit extremely close to the event horizon without being torn apart. The gravitational pull near a black hole is immense. As one approaches the event horizon, the boundary beyond which nothing can escape, time begins to slow dramatically for the observer compared to someone farther away. This effect is called gravitational time dilation, a real and measurable phenomenon predicted by Einstein. Spaghettification and falling in. Another terrifying aspect of black holes is what happens if you fall in. The term spaghettification describes the process where tidal forces stretch matter into long, thin shapes. It's a grisly fate caused by the difference in gravitational pull on different parts of the body. The closer you get to the singularity, the more pronounced this effect becomes. In Interstellar, Cooper survives falling into the black hole, something that would normally be fatal. However, the movie introduces a speculative concept, a tesseract or five-dimensional space created by the same advanced beings. Inside, time is experienced as a physical dimension. Cooper interacts with his daughter across time through gravitational anomalies. While this is a leap into science fiction, it builds on real concepts in theoretical physics like the idea of higher dimensions and the hypothesis that gravity might leak into them, which could explain why it is so much weaker than the other fundamental forces. Are wormholes and black holes real? Black holes are very real. They have been detected indirectly through gravitational effects on nearby stars and gas, and directly through gravitational wave observations, and the now famous image of a black hole captured by the Event Horizon Telescope in 2019. The image showed the shadow of a black hole in the M87 galaxy, a milestone in observational astronomy. Wormholes, on the other hand, remain purely theoretical. No observational evidence supports their existence. They are mathematically possible, but whether they can exist physically is another question. The requirements for stability, such as exotic matter, might be beyond the reach of our universe's natural laws. Still, their presence in equations keeps scientists and science fiction writers intrigued. Could an advanced civilization find a way to harness such cosmic tunnels? Could wormholes be created or stabilized artificially in the distant future? The legacy of Interstellar. Interstellar didn't just entertain, it educated. It brought complex scientific theories to mainstream audiences in a way that was both visually compelling and intellectually stimulating. Kip Thorne even published a companion book, The Science of Interstellar, to explore the real physics behind the film's most ambitious concepts. More than anything, the movie reignited public interest in space, time, and the mysteries of the cosmos. It reminded us that science and storytelling can work together to expand the boundaries of our imagination. As we continue to explore the universe, with telescopes, particle accelerators, and perhaps one day, with spacecraft venturing beyond our solar system, we may discover that the fiction of today becomes the reality of tomorrow. Until then, wormholes remain a beautiful idea, and black holes continue to challenge our understanding of space, time, and what lies beyond.